Hello there, Mr. Sutton here, bringing you the Algebra 2 Honors 6-5 homework solutions on properties of logarithms. For the first couple problems here, we're given some defined values of logs, log base 7 of 4 and log base 7 of 12, and we have to use these to evaluate this other logarithm, in this case log base 7 of 3, using some of our properties of logarithms. So the question is, how can I express 3 as a product, quotient, or some kind of power that involves a 4 and a 12? Well, 3 is 12 divided by 4, so maybe if we change it into that, we might get somewhere. So if I think of this as log of 12 over 4, I can use my division rule of logarithms where we turn it into subtraction to split this into pieces. So I can call this log base 7 of 12 minus log base 7 of 4. And now we can replace these values with the values they gave us up here. So this first one was 1.277, and then we had 0.712 for log base 7 of 4, and then I just have to subtract these on the calculator. So let me go ahead and do that. That's 1.277 minus 0.712, and that comes out to 0.565. For this next problem, I'm trying to find log base 7 of 48. And they gave me log base 7 of 4 and 12. So how can I turn 48 into something with a 4 and a 12? Well, 48 is 4 times 12. So let's break it up into that. And now I can use my property of logs where multiplication turns into addition of logarithms. So I can rewrite this as log of 4 plus log of 12. And just replacing those with our values up here, we have 0.712 plus 1.277. And I probably could do this without a calculator, but I'm going to use one just to be on the safe side. So on the last problem, I subtracted these things. Let me just add them together this time, and that's 1.989. For this one, we're trying to figure out log base 7 of 16 using these predefined values up here. So how does 16 relate to 4 and 12? Well, 16 is 4 plus 12. That's kind of an obvious one. Unfortunately, there's no rule for splitting up two things that are added together. So I have to turn this into either a product, a quotient, or a power. Thinking a little bit deeper here, 16 is 4 squared. If I split it, if I turn it into that, then I can use my pop-out rule of logarithms and pop out that 2 as a multiplier out in front. And now if I've got 2 log of 4, I can rewrite this as 2 times 0.712. And I can multiply that on my calculator. Let me just do 2 times 0.712, and that gives me a 1.424. To expand this logarithm, we have to first apply our subtraction rule, since we have division going on inside the log. So we can call this ln of x minus ln of 3y. But now this way, so it's easy on this point of the problem to just kind of move on and say, hey, I'm done. However, 3 times y is actually a product, so we are supposed to split that up. We're not allowed to have more than one constant or variable inside the logarithm. So I can split this up using addition. This is really ln of 3 plus ln of y. But I do have to put that in a parentheses after that negative sign. And since I have a minus parentheses, I can distribute this now. So this is ln of x minus ln of 3 minus ln of y. This one, we're trying to expand log base 7 of 5 radical x. To make my life a little bit easier, I'm going to rewrite this radical as an exponent. So this is really going to be x to the 1/2 power. And at this point now, I'm going to break this up using addition of logs. So log of 5 plus log of x to the 1/2. As a final step, I can't have exponents inside my logs if they're expanded, so I'll have to pop out this 1/2 in front. That'll be a log of 5 plus 1/2 log of x. To merge these logarithms, let's first start by moving the 6 and the 4 in as exponents. So this first term I can write as ln of 2 to the 6. And then we're subtracting ln of y to the 4th using our pop-in rule there. Now since I am subtracting these logs, I can actually divide them as inputs in one big logarithm. So this is going to be ln of, and I can turn this into 64 now, and then we have that divided by y to the fourth. To condense these logs, let's begin by using our pop-in rule to take care of those coefficients. So we've got ln of 2 to the fifth, ln of x to the seventh, and we're still adding that, and plus ln of y to the fourth. Now since I'm adding these logs, I can move them in together by multiplying their inputs. So we're going to have ln of, let's make this 32, x to the seventh, and y to the fourth. For this problem, we're told that the intensity of the sound of a television commercial is 10 times greater than the intensity of the television program it follows. I wonder if that's actually true. It would make sense. We want to know by how many decibels does the loudness increase. So they gave us this loudness formula here, where you take the intensity and plug it in. And the idea here is that we're just dividing the intensity by the intensity of some really small sound here that's barely audible. So how do I actually do this problem with this formula? Well, if we're talking about a loudness that's 10 times as intense, we're basically saying we have L of 10i instead of L of I. But now if I want to know by how many decibels does the loudness increase, I have to take the difference of those two loudnesses. So we have L of 10i minus L of I. And if I actually write that out, plugging 10i and I into this formula, I've got 10 log of 10i over I0 minus 10 log of I over I0. Now I can condense this a little bit, and maybe if I do that I'll be able to actually figure out a number for this. I can start by factoring out these 10s. So that leaves me with 10 parentheses, and then we have these two logs that are being subtracted in the same parentheses together. Now if I'm subtracting these logs, that means that I can divide their inputs. So I can write this in here as log of 10i over I0 divided by I over I0. But if I'm dividing by a fraction, I can actually just multiply by the reciprocal. So I'm going to skip a step here and call this log of 10i over I0 times reciprocal of this, I0 over I. And now at this point I can simplify a little bit. These I0s cancel out. I sub zeros are gone. The i's cancel out as well. So this is just 10 times the log of 10. And before I go for my calculator, this is log base 10, and we're plugging a power of 10 into it. 10 to the 1 is 10, so this is really just 10 times 1, which is just 10. And that unit's going to be in decibels.